Okay, yeah, welcome to my talk about working with large grid applications. Let me quickly introduce myself. My name is Harald Pehl. I'm working for RedHat, and I'm part of the Wildfly application server team. And my focus is working with the management-related tools. And I'm responsible for the Wildfly admin console. And that's actually the application we are going to talk about. The code name of the application is HAL, so that's why you see the picture. You can take a look at the code. It's available on GitHub, so it's open source. And feel free to take a look, and or even feel free to submit pull requests and to fix bugs. So pull requests are always welcome. So and to get an idea what the management console looks like, let's take a quick demo to the management console. So what you see here is the front page of the Wildfly management console. Just a quick question: who is familiar with the Wildfly application server? Anybody? And who has worked with the management console? Oh, not really so much. So for those who don't know the console, I give just a quick demo so that you know what it's all about. So what you see here is the home page of the management console. It's all about configuring and monitoring the Wildfly application server. So there are different sections on the screen, like handling or managing deployments. The main part is about configuring the application server, and it drills down to different profiles and so-called subsystems, which provide specific features of the application server. And for instance, you can enter the logging subsystem and change the log level of the application server, and then if you further change the console handler to display even or the debug statements, you should see in the runtime section, for instance, this is the section where you can monitor and view specific attributes of the server, of the different servers. And here, for instance, you can drill down to the log files and view the contents of a log file, and look for specific errors or debug messages. Though it's all about configuring and monitoring the Wildfly application server. And I would like to talk a little bit about this application and the origin of the application. And it all started back 2011. This was the first commit to the code base for the management console. And since then we had pretty much commits, and the code base grows rapidly. And we pushed out lots of releases in the meantime, and right now we are at the release 2.840 something. So this will be the one which will be a part of the next major release of the Wildfly application server, which should be published in a couple of days. And the code base is pretty big in the meantime. So we have something around 150,000 lines of code. Mostly it's Java code separated across different grid modules. But we also have a lot of CSS and less files in the code base, some JavaScript files. And it's all built with Maven. So we have these typical Maven configurations. And it's quite an effort to manage and to keep the code base really up to date. And Another fact is that we have to provide a community version and a product version. There is a community version which is shipped together with the Wildfly application server, and then there is a commercial offering from Red Hat, which is called the JBoss Enterprise Application Platform. And for this Enterprise Application Platform, we provide a slightly different version of the management console. It has a different look and feel and a slightly different feature set. But all in all, so 95% it's equal between the two versions, and then there are specific add-ons which are only available for the product. But the key point is that we have a really long period where we have to support and maintain and fix bugs. So it's up to 7 years. So each line of code we write today, we have to maintain up to 7 years, and that's something to keep in mind when it comes to implement new features or when it comes to change or refactor things. And yeah, that's why what we try to keep at a minimum are the dependencies for the application itself. So we started up with, or when the console was created back in 2011, we actually had the same dependency set more or less than we have today. So we started with the GWT framework from ArcBees, which we use to implement the model view presenter patterns. We are using Gin for dependency injection, and we use some helper stuff or some helper classes from Guava from Google, which are quite helpful for various things. And then we have small tools like a logging library, which gives us a way to inspect or to view inside the application without having to debug all the time. There are a couple of other dependencies, but we really try hard to keep it at a minimum, and that's from our experience a very good strategy to really think hard and think twice before adding a new dependency to your project. If you really need it, most often you have specific features in Quid itself. So we try whenever it's possible to use the thing which is provided by Quid itself, like client bundles, request factories, and all the things which come with the framework itself. And only if you're really sure that you don't have or you're missing something, then you should think about adding a library or a framework. So next I want to quickly talk about the architecture, just some key points, how the management console is built. We are using Maven to build an architecture. I think most of the Quid applications rely on Maven for building the stuff. It's quite useful, and we basically have one Maven module for the one Quid module, so which shouldn't be which should be quite normal. And then we make heavy use of annotation processors. We already heard today that it's really a powerful concept, and it definitely is. So we have a few Quid generators in place, but we want to replace them step by step and use annotation processing to generate our code. We heavily rely on code splitting, so that's something because our application is quite big. And for the product version, we have to support 6 to 7 languages. So there are lots of permutations involved, and though the whole application is quite big. And with GWT, the code splitting is quite easy to implement. You just have to place an annotation on the proxy of your presenter, and then you already have most of the things in place to make use of the code splitting. And as I already pointed out, we really try hard to use what comes with the framework, with the Qt itself, and stick to it. So we don't use any external widget library, for instance. We're using vanilla widgets, but I will show more details in a second about that. Yeah, and we are using the model view presenter patterns to implement the UI. As you see as you've seen in the demo, the screens look all the same, or there are some patterns behind it. So the UI is built programmatically. And we found out over the time that it's really a good idea to use the composition over inheritance. We used to have a mini framework inside the management console which heavily relied on inheritance, and it was really hard and cumbersome to develop with it. And finally we got rid of it. So nowadays we found out that it's much easier to have some building blocks and to assemble your screens or your presenters by reusing components and to composite things together. And yeah, over time there is some code which we factored out into small mini libraries, which I quickly want to introduce. And this is some kind of spin-offs which we created in the last couple of months or so. And the first is about dealing with asynchronous calls. This is nothing which is now provided as a standalone library. It's still part of our code base. But if there's interest, we could give it its own code base and make it available to others. And the second one is SoQuit. It's about Dataflow. And I just want to give a quick example for both of these little toolkits, if you like. So the first one is about managing asynchronous calls. Yeah, I think all of you know that making several asynchronous calls which depend on each other it's not fun at all. So you end up with a callback inside a callback inside a callback, and the code is really hard to maintain and hardly readable. And that's why we came up with a little helper class which makes it more easy to execute these calls or these functions in a coordinated manner. So the idea is to encapsulate your logic into functions, and then you can assemble the functions in something like a pipeline. And a good example, we often face situations where we deal with resources. Resources are a server-side concept of the application server, and we have to create or modify resources. And most often we want to do it in a lazy way. So we want to check if the resource exists. If not, we create it, and then we modify it with the values given by the user. And that's a perfect example for although each of these functions has an asynchronous call. So that's just an example how we look for whether a resource exists. So we execute an operation asynchronously to check whether a given resource of a given address exists or not, and then we have a context, a common context, and we push an 404 if it not exists, and we push a 200 if it exists. And the second function then reads this state and creates the resource if it's not there, and otherwise it just passes over to the next function. And then finally we have this modify function which has a bunch of user values, these changed values, which is just a hash map of the values typed in by the user, and execute the function to modify the resource. And then we have this async class with some helper class methods. In this case, there's a method called waterfall, which just executes the functions one by one. And this way you can easily read what's going on, or have a notion what the actual program flow is. Yeah, and the second one I quickly want to introduce is another spin-off which we created in the last time is called SoQuit, and that's inspired by a pattern taken from the React.js framework, and it's about having an idea or having a way to control your data flow in your application. So you often deal with events or with callbacks. And it's most of the time it's really hard to find out what kind of action is triggered by what event, and what event triggers what asynchronous call. And somehow we wanted to find a way how to manage it, and then we came across this concept published by the React.js framework, and it's an idea to have a dispatcher, a single dispatcher in your application. And to have so-called stores, which are just classes where you hold state, and the state is then changed by actions which are dispatched by the dispatcher. And the good thing is that the stores can have dependencies between each other, and that the framework guarantees that one action is only executed at a time. And this is also guaranteed if you have asynchronous callbacks. And some example for it, some hypothetical example is something like if you want to dress up, and you normally first put on your underwear before you put on the trousers and then put on the shoes. So otherwise, and the reverse thing is then if you like, the undress action. So this is something just to have a better example, or to have a better understanding how this could look like in the code. And so, for instance, a trouser store, if you like, would then be annotated with an annotation. So this whole concept is based on is backed by an annotation processor, which generates the necessary code. In your store, you have then different methods, and you annotate the methods with process annotations. You specify which action you want to process in your method, and you can optionally have dependencies on other stores. And in this example, the dress action is first processed by the underwear store, and then by the trouser store. It's all about having an order, or having a notion of your data flow, and which action is executed by which store. And then you have to somehow implement your action, though the actions are just marked with a marker interface. And normally you would have some kind of payload inside your action. So you have, when you, for instance, want to create a resource, you can have a create resource action, and inside the action you would have some kind of payload about the parameters or the attributes. And then we have different implementation of the dispatcher. In this kind, there's a dispatcher which guarantees this given order of the actions, and then you can then you dispatch your action, and the various process methods will get called from the framework. This helped us a lot to clean up the presenters and to clean up the state. So it's all about having the state in one place, and having a very strict way to change the state and the state. So if the stores can reference each other, and it's always safe that the state is valid. So yeah, finally I want to talk quickly about the UI in which we're using in the management console. So we we decided against using the UI binder. This is partly a personal opinion, partly it's because we have very specific needs, or there are some common layouts throughout the management console, and we find out that it's more easy to really program them by hand or programmatically. So we can use the builder-like APIs and have building blocks and assemble them together. And as I already pointed out, we are just relying on the grid widgets, so like the text boxes, or actually what's there. And we heavily use cell widgets for the tables and for various other places. And they are styled with external CSS. So this is based on a project called Patternfly, which is an effort from RedHat to have a common look and feel across all the management-related UIs. Here's a quick code snippet how that looks like. So we have in that case a multiple to one layout builder. And we often have this master detail view in the console, where you have a table at the top, and you select an entry, and then you have the properties separated across different tabs at the bottom. And we are using these all over the place to define what's inside the table, then add the details which end up as tabs. And inside the tabs, there is these forms, and these forms have a little state machine inside it. So normally you first see the read-only view, then you have the edit link, and then it switches to a form where you can modify the values, and then you have this save and cancel button, which trigger an event handler. Yeah, so the lessons we've learned implementing the management console is really to try to keep it simple. So that's these points are not really new or revolutionary. It's well known since years, but we try to follow them. So we try to keep it simple and use what's in the framework, or what's coming with Grid itself. We try not to use too much inheritance, because it's tend to become very inflexible if you over-engineer it. And we do not we do copy and paste a lot. So that's due to the reason that we have this long maintenance support guarantee. So we found out it's easier to have if you chase bugs, or if you want to fix a bug, that you have a distinct place where you fix the bug, and you are sure if you fix this bug, then no other areas of the management console are affected, for instance. That's why we often do really copy paste, and then when we find that it's really too much, then we can factor out or encapsulate later on. This is how these mini frameworks have evolved over the time. So we do then from time to time refactorings, but we are very cautious that not to break stuff, because we have this long guarantee of maintenance. Yeah, and that's basically it. So thank you, and I think we have some time for questions.
Yes.
Yeah.